In this video, we will be talking about the trig identities and also solving trigonometric equations, but that will be a later video. So these identities should be very familiar to you from trigonometry. So I do kind of have an expectation that you should probably memorize these guys, even though you will have your notes for exams because of quarantine life, but you should at least know some of the basic ones, okay? So I'm not going to go ahead and derive them. That probably you have seen already in trig, but these are very easy to do, the reciprocal quotient and Pythagorean. Double angle are very useful, especially when we're trying to reduce a couple of problems, and even when we do some equations, it's a little easier to work with the double angle, or maybe if you want to go back to the single theta. Sum and difference, cofunctions. These cofunctions you have probably seen a lot, especially when we're looking at sine and cosine, and when we're shifting and reflecting. And then half angle and half angle identities are also pretty useful, but the ones that I think that you're gonna really look at, especially in Calc 2 and in Calc 3, are the reduction formulas. So when you're reducing a power to a single power, these are super duper important. So if there's something that you need to really know, it's these guys. All of these guys are important, but these are kind of like the most general ones that you really want to make sure that you know, have handy somewhere or another, because they will help out with a lot of the calculus that we do. Now notice that there are two of them that I'm neglecting, which is a sum to product and product to sum formulas. They exist. I don't really care for them, so I mean, you can go ahead and take a look at them in the book, but I'm not going to go ahead and talk about those. These are the ones that I really want to look at. So what we're going to do is that we're going to take a look at some of these identities and do a little bit of problems, and we're going to use each of the identities or the identity that best matches the problem that we are given. So so let's do a couple of examples. So here, let's find the exact value of cosine of pi over 12. Now, one thing that you could do is you can just put cosine pi over 12 in the calculator. But what I want to make sure that you know how to do also is be able to give the exact answer of the cosine of pi over 12. So if you think about our unit circle, so here's our unit circle, you can see that pi over 12 is not on there, but we know that we got pi over 6, pi over 4, and pi over 3. So how can we possibly get pi over 12 from these three different values? Because pi over 12 is a little bit less than pi over 6. Well, if I take pi over 4 and subtract pi over 6, I will get pi over 12. So I can rewrite this as the cosine of pi over 4 minus pi over 6. And if I do that, I will end up getting pi over 12. So now that I did it as a difference of two different angles, I can go back up and use the sum and difference value for cosine. So cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. So just be careful with that plus. These guys are the opposites. So when it's plus, it's going to be minus. When it's minus, it's going to be plus. Okay, so in this case, you're going to have cosine. So let me write it up here. So cosine alpha minus beta is going to be cosine alpha cosine beta plus sine alpha sine beta. So I'm just going to go ahead and plug in these angles into the formula. So you're going to get cosine of pi over 4. Then you're going to get the cosine of pi over 6. Then plus the sine of pi over 4 times the sine of pi over 6. All right? So now we know that the cosine of pi over 4 is square root of 2 over 2. We know the cosine of pi over 6, that's going to be square root of 3 over 2. Plus the sine of pi over 4, that's going to be the square root of 2 over 2. And the sine of pi over 6, that's going to be 1/2. So what you're going to get is square root of 6 divided by 4 plus square root of 2 divided by 4, which gives me square root of 6 plus square root of 2 divided by 4. All right, so this would be the exact answer of cosine of pi over 12. So this is what you have to do, kind of break them up with known angles and then use one of the sum and difference identities. Okay, now let's go ahead and do cosine of 15 degrees using half angle formula. So you can see that this guy you could have easily done maybe 45 degrees and subtract the 30 degrees to get the 15 degrees. But now we want to use the half angle formulas. So the cosine of 15 degrees. So let's go back up and look at the half angle formulas. And the half angle identities right here will be a cosine of alpha over 2 is equal to the plus or minus square root of 1 plus cosine of alpha divided by 2. So let's go ahead and write that down. So we have the cosine alpha over 2 is equal to plus or minus square root 1 plus cosine of alpha divided by 2. Okay, just double check, make sure that I did this right. We don't want to mess this up. Okay. All right. Now remember, what we really want is to reduce this cosine of 15 degrees into an angle that we know, and we divide by 2, and that will give me 15 degrees. So the only number that I can divide by 2 to get 15 is 30. So we're going to let alpha be our 30 degrees. So this alpha, let me make it into a highlighter. This alpha is just going to be this 30 degrees. So then I'm going to get the plus or minus square root of 1 plus the cosine of 30 degrees divided by 2. Now notice here we can actually drop one of the plus or minus. This just depends on what quadrant you're in. Because 15 degrees is in quadrant 1, it'll make sense for us to just use a positive sign. So I'm just going to use the positive square root. So the cosine of 30 degrees is just going to be square root of 3 over 2. So I'm going to have the square root of 1 plus square root of 3 over 2 divided by 2. And then I can go ahead and do a little bit of reduction. So on the top you'll have 2 over 2. So 2 over 2 plus square root of 3 over 2 divided by 2. This gives me square root of 2 plus square root of 3 divided by 2 over 2, which gives me the square root of 2 plus square root of 3 divided by 4, which in turn gives me the square root of 2 plus square root of 3. And then if I take the square root of 4 on the bottom, I'm going to get 2. So this would be as reduced as it will get. Okay, so this will be the exact answer for the cosine of 15 degrees. All right, now let's look at this next example. So we are given that sine phi is equal to 5 over 8, and phi is between 0 and pi over 2. So let's find sine 2 phi, cosine 2 phi, and tangent 2 phi. So it looks here that we're going to have to use a double angle identity. So one of the things that I like to do is that I let you locate this sine phi of 5 over 8 on your coordinate axis. So I'm going to draw my x and y plane. And then we know that phi is from 0 to pi over 2. Well, that's just from 0 to 90 degrees. So we're going to draw a triangle over here. And here is a 90-degree angle. Here is phi. We know that sine is the opposite over the hypotenuse. So you're going to have 5 and then 8 over here. Now we need to figure out our angle A, or our side A. So we're going to use Pythagorean. So we're going to have a squared plus b squared equals c squared. So our A is going to be what we're looking for. Our B is going to be 5 squared, and our C is going to be 8 squared. Okay, I don't know what that is. 64 minus 25 gives me 39. So A equals a very ugly number, square root of 39. Okay. All right, so now that we know what A is, which is square root of 39, and we know that we're going to look at the positive side, because in quadrant 1, everything is positive, we're going to we need to use the formulas for the double angles to figure out the rest of the guys. So let's start off with sine of 2 phi. Sine 2 phi. Oh, for those that don't know, this symbol means phi, or phi. So let's go back up and look at sine 2 phi. So we're going to look at the first one. So 2 sine theta cosine theta. So let's go ahead and write that down. So this is going to be 2 sine theta cosine theta. Or it's going to be sine phi cosine phi. So we got a 2 there. The sine phi, we already know what that is. That's 5/8. cosine phi, that's going to be the adjacent over the hypotenuse, which is the square root of 39 over 8. So this is going to give me 10 square root of 39 divided by 64. And I think you can reduce that a little bit. 10 over 64, that gives me 5 over 32. So 5 square root of 39 over 32. So this guy will be the sine of 2 phi. Now let's look at the cosine of 2 phi. So if we go back up, the cosine of 2 phi, you actually have 3 different options. They're all going to give you the same thing. I'm just going to work with the first one, cosine squared minus sine squared. So I'm going to use cosine squared phi minus sine squared phi. So the cosine, we figured it out in the previous one. That's square root of 39 over 8 squared. And the sine is just a 5/8 squared. So this is going to give me 39 over 64 minus 25 over 64. Okay, so we're going to take that 39, subtract the 25, gives me 14 over 64. Okay, which also reduces to 7 over 32. And now we're going to look at the tangent of 2 phi. So if you look at the tangent, the double angle for the tangent is going to be 2 tangent over 1 minus tangent squared. So 2 tangent over 1 minus tangent squared. 2 tangent. All right. And if we look at the tangent's going to be just the opposite over the adjacent. So it's going to be 2 times 5 over square root of 39 divided by 1 minus 5 square root of 39 squared. So on the top, you're going to get 10 over square root of 39. You're going to get, I'm going to make the 1 into a 39 over 39. And this guy's just going to be 25 over 39. So this is going to be, let me write it down here, 10 over square root of 39 divided by, so I'm going to take 39, subtract the 25, that's going to give me that 14 over 39. So what would this give me? Divided, so flip. So I'm going to get 10 over square root of 39 times 39 over 14. Oh gosh, I don't even know what that is. Okay, so 10 times 39, and I'm gonna multiply this by, so divided by 14. So I get 195 over 7 times square root of 39. Okay, so not a pretty number. So check my math, make sure that everything I'm doing this right. Okay. But this is basically it. So you're basically just plugging and chugging, making sure that you use geometry to figure out the rest of the triangle, right? And then after that, just plugging it in. All right. So now let's use the reduction formula to reduce cosine to the 4th power x. Now this might seem pretty useless, but it's actually really, really useful in Calc 2. So you'll be doing this a lot more in Calc 2. So we're going to do it to the 4th power. Okay, so one way that we can reduce cosine to the 4th power, right? So notice that we want this so that there's no powers of sine or cosine greater than 1. So if you look at the formulas, we don't have anything that has to the 4th power in the reduction formulas. But is there a way that I can reduce the 4 to the squared? So one thing that I can do is I can make this into cosine squared x times cosine squared x, because this can give me to the 4th power. And now I can apply the reduction formula. So the reduction formula says that cosine squared x is equal to 1 plus cosine 2x divided by 2. Okay, so let's go ahead and do that. So the first guy is going to be a 1 plus cosine 2x divided by 2 times 1 plus cosine 2x divided by 2. So I'm going to notice that I get a 4th down here. I'm going to pull that out. And I get 1 plus cosine 2x, 1 plus cosine 2x. I'm going to FOIL all that out. So I'm going to have 1 plus 2 cosine 2x. And then the last one's going to be cosine squared 2x. All right. So it looks like I'm basically done, but notice that when I FOIL this thing out, I ended up getting another cosine squared x. All right. So here's the tricky part, because we don't have a cosine squared 2x. But notice that if I have cosine squared x, right, notice that what happens is that when I have 1x here, you have 2x's here. So basically the argument just doubles. So you can see that this x to this 2x just doubled. So that means cosine squared 2x is just going to be equal to 1 plus cosine 4x divided by 2. So you can see that here, this guy is just going to be doubling the argument. So we're going to use that detail. So I'm going to have 1/4 1 plus 2 cosine 2x, and then the cosine squared 2x is just going to be what we just figured out, which is going to be that 1 plus cosine 4x divided by 2. So this guy's going to give me 1/4 1 plus 2 cosine 2x plus 1/2 plus 1/2 cosine 4x. So all I just did there was I just broke up this fraction. I divided this 2 into both of them, into the 1 and into the cosine 4x. And it seems that the only thing that I can just do is just add the 1 and the 1/2, which gives me 3/2. So we have 3/2 plus 2 cosine 2x plus 1/2 cosine 4x. And I have no more squares. Everything is a cosine to a power of 1. Everything is all good. So you might be wondering what the heck was the whole purpose of this. And you're actually not going to know the purpose until Calc 2. But typically what's happening is that in Calc 2, integrating, so don't freak out, but integrating something that looks like this is really difficult, okay, in the Calc 2 area. You can't really do calculus with this function. This function is really hard to integrate. However, it may seem a little bit weird, but actually integrating this guy is actually a lot easier than integrating something like that. I know, this looks a lot more complicated, but actually, in calculus, this is a lot easier to work with than something to a power of 4. Okay? So we'll continue with the other identities in the next video.